So our first molecule that we are going to do is CO2. CO2 has 16 valence electrons. We get that from carbon. We have 4 valence electrons plus 6 times 2. And then we can draw our Lewis dot structure. We have carbon double bonded to oxygen twice. Oxygen has 4 valence electrons each. Carbon has 0. The electron domain geometry is going to be a linear geometry with the same shape is also going to be linear. So the bond angle here is going to be 180 degrees. And then for delta notation, we know that it's negative delta on the oxygens and positive delta for the carbon. And then the arrows are going to be going the negative direction towards the oxygen. And we have 2 polar bonds, 2 polar covalent bonds. And they cancel each other out to make the molecule as itself nonpolar. And then the hybridization for this atom is going to be SP. So now the formal charge, so the formal charge of carbon is going to be 4 minus 0 minus 8 over 2 for a charge of 0. Put that on the carbon. And then for the oxygen, we have 6 minus 4 minus 4 over 2, which comes out to 0 as well. Then we can move on to our next atom, which is going to be CO3. So CO3 has 24 valence electrons. We have our carbon, which is going to give us 4 plus 6 times 3 plus 2 for the negative charge. And when we draw our Lewis dot structure, carbon is going to have 1 double bond and 2 single bonds with oxygen. Double bonded oxygen is going to get 4 valence electrons, and the single bonded oxygens are going to get 6. The delta notation is going to be positive delta in the middle. Oxygens are going to have negative delta. The arrows are going to go the same direction as before. Negative going out, positive in. The electron domain geometry for this molecule is trigonal planar, and the shape is the same, trigonal planar. The bond angle is going to be 120 degrees. We have 3 polar bonds, and they cancel each other out, so the molecule itself is non-polar. And then the hybridization for this atom is going to be sp2. And then for the formal charge here, we have carbon, so it'd be 4 minus 0 minus 8 over 2, which gives us 0 for carbon. And then the oxygen that is double bonded is going to have the formal charge is 6 minus 4 over 2, so that's going to be 0. And then the other 2 oxygens are going to have a formal charge of 6 minus 2 over 2. So they're each going to be negative 1. So the overall charge is going to be negative 2, which matches our charge on the molecule. Oh, almost forgot. So these are our 2. So let's actually flip back to the first one right here. We went ahead and made our structure right here. We have carbon in the middle, and then we have oxygen on the outsides, and they're both double bonded. We went ahead and used some Starburst candy and toothpicks to make this. And then over here, our CO3 atom, we have this similar setup. Blue is carbon, and then we have green as the oxygen for this one. We have 1 double bond and 2 single bonds. So our next one is going to be H2O. And H2O has 8 valence electrons. 1 from hydrogen twice. So that's 2 plus 6 from oxygen. It gives us 8 valence electrons. So when we draw this, oxygen has 2 lone pairs and 2 single bonds to hydrogen. Hydrogens have 0 lone pairs on them as well. So there's our Lewis dot structure, and the electron domain geometry for this is going to be a tetrahedral, and the shape is going to be bent. And then the bond angle for this one is going to be 109.5 for each side. And then when we look at our delta notation, we have negative delta for the oxygen, and we have positive delta for the 2 hydrogens, because oxygen is more electronegative. And then we have our arrows pointing inwards, positives at the hydrogen. So this gives us 2 polar bonds. And these bonds do not cancel out, and the molecule itself is going to be a polar covalent molecule. Or actually, no, it's just going to be polar. My bad. And then the hybridization for this molecule right here is going to be sp3. And then when we're looking at the formal charge for this, the formal charge for oxygen is 6 valence electrons minus 4 over 2 comes out to 0. And then the 2 hydrogens is going to be 1 minus 0 and then 2 over 2. So 0 for the formal charge for both of them. And then our diagram that we made for this one looks like this. We have the red starburst as oxygen, and then the pink one is going to be hydrogen. And then to represent our lone pairs, I just used toothpicks with nothing attached, just sticking out right here. So we have 1 lone pair on this side, 1 lone pair on this side. Next molecule is going to be PF5, and this one has a whopping 40 valence electrons. So we get this from fluorine, which is 7 times 4, plus the phosphorus, which, let's see, 728. Oh, my mistake, it's actually 5. So that gives us 7 times 5 is 35, so phosphorus must have 5 valence electrons. And so we can go ahead and draw the Lewis dot structure for this one. We have phosphorus, and then we have 5 fluorine atoms attached. Each fluorine has 6 valence electrons connected to it. And then for our delta notation, the phosphorus is going to get the positive delta, and then all the fluorines are going to get negative delta notation. And then the arrows are going to be pointing outward with the positive sign in, because fluorine is the most electronegative element. And so the electron domain geometry for this one is trigonal bipyramidal, and the shape is trigonal bipyramidal as well. So then our angles right here are going to be 90, and then we're also going to have some 120-degree angles. So these 5 bonds are polar covalent bonds, but they all cancel out, and we end up getting a non-polar molecule. And then our hybridization for this molecule is going to be sp3d. And then when we look at our formal charge for this molecule, we know that the total charge is going to be 0. So phosphorus 5 minus something over 2. So it's unbonded. So unbonded electrons is 0, and then bonded is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, there we go. Gives us a formal charge of 0. Almost forgot that one. So then fluorine has 7 valence electrons, minus it's unbonded, which is 1, 2, 3, 4, 5, 6, minus it's bonded over 2, 2 over 2. So we're going to have 0 charge for that as well. All right, and then we are on to our last, oh, almost forgot. So this is our phosphorus pentafluoride molecule, I think is how it's pronounced. We have phosphorus in the middle, connected to our 5 fluorine atoms. Now on to our last molecule. We have xenon, or XeF4. So our total valence electrons for this one are going to be 36 valence electrons. And we get this by 8 plus 7 times 4. 28 plus 8 is 36. So the Lewis dot structure for this one is going to be Xe in the center with 4 fluorine atoms connected. But then in the center, we're also going to have 2 sets of lone pairs. And the fluorines are all going to have 6 valence electrons attached to them. So the electron domain geometry for this one is going to be an octahedral with the shape of square planar. The bond angles for these are going to be 90 degrees. Then we look at our delta notation. Fluorine is going to be negative delta because fluorine is the most electronegative element. And then positive delta for our xenon gas. And then our arrows are going to be pointing towards fluorine, positive side towards the xenon gas. So the bonds between these 4 are all polar bonds, covalent bonds, but they all cancel each other out, and the molecule itself is a non-polar molecule. And then the hybridization for this atom is going to be sp3d2. Then all that's left is to determine its charge. So for xenon, we have 8 for its valence electrons, minus 4 for its unbonded valence, or unbonded electrons, and then minus 8 over 2 for its bonded electrons. That's going to give us a total of 0. And then the fluorine is going to be 7 minus its 6 unbonded, minus its 2 bonded over 2. That's going to give us a charge of 0. So we have 0 charge, formal charge, for all of the electrons, or for all of the atoms. And that is it. I hope I didn't forget any. I did forget something. My camera person is alerting me to that. We have our final structure right here. Our pink one is xenon, and fluorine is going to be our red ones right here. And then we have our 2 pairs of lone electrons up the top and on the bottom right here. All right, and that is everything. I hope I am not forgetting anything. And that is the end.